Okay, this model is called data privacy in blockchain. Are they compatible? So let's see, we just analyzed the data privacy legislation and in particular the key elements, the principle and the requirements of the GDPR, so the European GDPR. But we're now going to move forward and discuss and answer together questions of this second module. In particular, the question that I would like to answer with you is what is the connection between data privacy and blockchain, and what are the main privacy tension and concern that needs to be considered while developing blockchain applications. So, what lesson we're going to learn in this model? We're going to first to highlight the connection, the interplay between data privacy and blockchain, if there is any, and then we're going to deep dive into this, into the main key privacy issues of blockchain solution that we should really look at in order to develop the right solution for the expected outcome. And so, first of all, why is the connection between data privacy and what is the connection between data privacy and blockchain? Well, these models maps what is this connection. And so, first of all, if and how data protection laws applies to blockchain solution, which are the key privacy tension and concern that need to be considered while developing a blockchain platform. And what I would like you really to bear in mind is that specific elements of data protection legislation, and in particular the GDPR that we just analyzed, even if briefly, and we're going to discuss today more in details, always need to be determined on the basis of a case-by-case analysis. But of course, there is always space for general consideration regarding the connection between blockchain and data privacy. So that's what we're going to do today, discuss this general consideration. So the analysis will need really to start with an overview of the circumstances under which the data protection laws applies to blockchain application. And also, even if the compatibility between blockchain and data protection laws can only be established on a case-by-case basis, as I already mentioned, that really need to take into account technical but also contextual factor, for instance, the governance framework, their relationship can be introduced, and you will see I introduce it in the next slide, really in view of drawing attention to a specific aspect of blockchain and data protection framework. And so what is this connection? Let's see if blockchain application is going to be affected by the implications set out in the data privacy law. And in order to do so, we need to discuss the applicability of privacy laws and the territorial implications. So data privacy laws applicability. So first of all, the privacy rules apply generally to the processing of personal data. And so to determine applicability of the privacy rules, it should therefore be assessed whether personal data are processed when blockchain technology is used. So we need to understand, is our solution treat personal data, and if personal data will be stored on blockchain. And that's because the applicability of most data privacy laws, including the GDPR, but not only the GDPR, I'm thinking also about the California Consumer Privacy Act and other legislation around the world, depends first on whether the activities in question involved the processing of personal data. And we do all know that in a blockchain, all transactions are published publicly, and so they're available for all participating nodes in the system, if you talk about a public blockchain, of course. And so in most applications, the published transactions are not encrypted. And so if this information is important and is related to someone, or it is personal data, then this can create regulatory legal problems. Again, understanding the interplay between blockchain and data privacy law should take place on a case-by-case basis by really analyzing where the personal data appears, how it is processed, and who is responsible for that processing. That's because, for instance, it can happen in a blockchain using a supply chain environment and not necessarily implicate data privacy concern if, let's say, all blocks include is hashed information about the details of a transaction, but the information does not contain or cannot otherwise be linked to an individual. In that case, there are not personal data involved, complicated, because often are involved even in a supply chain environment. But if so, of course, we're not, the data privacy regulation will not be applicable. On the contrary, when the information is or can be linked to an individual, then data privacy concerns have to be properly considered. And so implementation involving personal data, blockchain implementation that involve personal data, really must be carefully constructed to comply with applicable data privacy laws. And even to choose the right law will be difficult because of territorial consideration that we're going to see now. So because we need, of course, to see whether the territorial scope of data privacy legislation applies in a blockchain environment. And this because the distributed nature of blockchain technology pose a challenge regarding the applicability of various jurisdiction laws. Data privacy laws generally apply according to one or two criteria that are the individual locations, the personal data processing location. For example, when we discuss, if you think about the the California Consumer Protection Act, that apply to personal information of California residents that are involved, regardless the business processing location. When we look at the GDPR instead, it applies to personal data processing activities by either controllers or processors that are established in the European Union, but also in the economic European area. And also regardless of their location, if the personal data processing involves offering individuals good or service in the European Union, or even online behavior monitoring of individuals in the Union. So defining the jurisdiction and determining the regulation to apply to decentralized blockchain solution is a very complex matter, and this especially if we compare it to traditional centralized system. Of course, in the case of private blockchain, it's possible to set restriction in their governance models, and so agreement that can limit regulatory scope. But in the context of public blockchain that process personal data, a best practice could be, for instance, to apply different data protection laws. But again, many problems can arise as well, because managing this regulation can raise significant overhead costs, and also using common public-private key pairing for encryption may really bring them in many regions scope. So if we look at the GDPR's, for instance, broad territorial scope, probably entails that its obligation bind many blockchain-based applications that have only even an indirect link to the union. That's why also I find interesting to focus on this legislation. And now moving to another question, relevant question of this masterclass. What are the key tensions between blockchain technology and data privacy? Now, in order to answer the question, I really believe it's relevant to highlight that the central feature of blockchain technology is a shared ledger based on consensus. We know that it is a shared ledger because the member of the network can have access to information, depend on the type of permits and keys available. And every participant has a copy of the ledger that contains the whole story of the transaction. And so to facilitate the understanding of the key tension between blockchain and data privacy, it is interesting to look at the blockchain core advantage, at least some of them that are relevant for the topic of the data privacy. That are decentralization, because we all know that this feature differentiates the blockchain from centralized transaction systems where each transaction must be validated by the central trust agent. Immutability, since every transaction we all know that take place in the network, they must be confirmed and recorded in the blocks distributed through the network. And so it is almost impossible to alter them, to falsificate them. And any falsification will be easily detected. And in fact, no single party can change transaction recording in the shared ledger. And then we do also have other important core advantages, such anonymity, the transparency, verifiability, the data sharing. But I won't focus on that. I just wanted to really point out these two aspects of the decentralization and immutability, because we will see they could be particularly relevant when discussing about data privacy rules and the compliance with data privacy rules. And then, of course, it depends also when we discuss about data privacy, we also need to distinguish about, depending on the type of blockchain, if we're talking about public or private blockchain. And so, but just in general, I want to underline that it's really difficult to make current data protection requirement compatible with blockchain technology characteristic, and in particular, with the lack of a centralized console with immutability and perpetual data storage that are in evident conflict with the data privacy requirements that we just analyzed in module 1. And unfortunately, another thing that I would likely to share with you is that there is no regulatory guidance, or it is very limited on reconciling this and other potential conflicts. At the moment, at least in Europe, the only data protection authority, it is the French Data Protection Authority, that has formulated a guidance with initial recommendation on blockchain related to the compatibility between blockchain systems and data privacy. But this actually, Data Protection Authority calls on the European Union to formulate solution on a regulatory level. So again, we can look at this recommendation. I suggest you to look at them, but we need to explore also different solutions. So that was just a premise to say that the one that you can see in this slide are probably the main tension that has been identified between this technology and data privacy requirement. I'm not going today to go into the details of all of them, because I can see it's already 6, but I just really wanted to highlight them, underline the need to put in place a privacy-friendly blockchain solution. So understand this tension, this concern, take them into consideration in order to develop a mitigation strategy. And also I would like to point out that GDPR compliance or data privacy compliance is not about the technology. So it is about how we use the technology. So we're not looking for a GDPR compliant blockchain. We are looking for a GDPR compliant application use case. So that's because they're not like GDPR compliant artificial intelligence or GDPR compliant internet. So we need to look really at the specific use case, and in order to develop a use case that is compliant with the GDPR, a blockchain solution compliant with data privacy legislation. Now, let's see very briefly which are these important tension to consider. Different perspectives on anonymity and pseudonymy, how to identify the data controllers and the data processor in various blockchain technology implementation. And we have seen that these two actors are really relevant. Then we do have some privacy principle that we'll see later that we already discussed, the data minimization, the purpose limitation that are particularly relevant, and we need to see if they're compatible with blockchain. And then individual rights, so data subject rights, if it's possible to ensure data subject right in a blockchain environment. These are the most, that's important one, the one that we'll try to address today. Then also there are other aspects, such when cross-border data transfer occur and potential restriction on them, and also applying criteria for legitimate reason for processing personal data to blockchain use. So these are other aspects that I suggest you to analyze. So here we are, personal data, anonymity, pseudonymity. So we have seen already what is personal data under the GDPR. the question is, are data stored on blockchain personal data? That's a very important question, because we've seen that only when personal data are involved, then data privacy laws applies. So we really need now to analyze whether the data stored on blockchain are personal data. And as described in the first model, personal data can be defined as any information that belongs to a natural person, which is collected, recorded, and stored. And this this natural person, we call it data subject. So the data subject may make transaction through a pseudonymized system. And unfortunately, we've seen already that according to the GDPR, pseudonymized data remain personal data, because all the data that make a person identifiable directly or indirectly can be, for instance, the name, identification number, the location data, still is personal data. And so pseudonymization falls within the scope of this regulation. As a consequence, blockchain technology could definitely fall within the scope of this regulation if the data is transferred pseudonymously between different participants on the chain. And this because the data protection regulation do not apply only to anonymous information. And so there are the information that does not relate to an identified or unidentifiable nature person, and to the personal data that renders sufficiently anonymous that the data subject is prevented or is no longer identifiable. And so basically it applies always the GDPR unless the data has been anonymized. But there are difficulties in anonymizing personal data in a blockchain environment. There are really a lot of debate within the community. So referring to what specific technique may be used to turn personal data into anonymous data. In the blockchain context, anonymization are particularly difficult due to the presence of two risks, actually. The reversal risk and the linkability risk. The reversal risk, so the possibility of reversing the process and reconstituting the original data using, let's say, the decryption process. And linkability risk, that is the risk that encrypted data can still be linked to an individual by examining the overall context or comparing it to other information. And so as long as the key exists somewhere, then the data can be decrypted. And this is especially true if we think about the constantly evolving science of cryptographics. So anyway, I would like to underline that really when we discuss about personal data, that is something that also the data protection French authority say. When a blockchain contains personal data, well, the GDPR is always applicable. So an implementation, blockchain implementation that expressly store personal data on the blockchain are subjects to law regarding personal data. However, whether the data some blockchain record, process, or use to manage transaction qualifies personal data, that really varies. So this is what we need to understand. And then it's important to make a distinction to transactional data and public keys. Because depending on the specific case, then a data stored in blocks may be data related to an identifier or data related to an identifiable nature person. It can include, let's say, data revealing behavior in Internet of Things use case or digital identity, or even in financial or medical data. So in order to distinguish this data, which often contain personal information, from other data, such as personal key, we could refer to them on transactional data. When we discuss public keys, we refer to strings of letters and numbers that allowed for the pseudonymous identification of a natural or legal person or a machine for transactional or communication purposes. And you may already know, of course, that there are different ways to store on-chain data, so in plain text or in encrypted form or hashing it to the chain. And so we really need to evaluate whether these processes can anonymize personal data and so not fall into the scope of application of the GDPR. Well, again, if personal data on a blockchain are stored in plain text, that's clearly they remain personal data for the purposes of the GDPR. So they need to follow the rules of the GDPR. When data is encrypted, it can still be accessed using the correct keys, meaning that actually these data are not irreversibly anonymized. And so encryption is a method of pseudonymization under the European Union protection regime. And so that's because the data subject can be still indirectly identified. And so as a consequence, it cannot consider on its own as an anonymization technique. And so that means that even encrypted data will be considered as personal data. And transactional data that has been subject to a hashing process also can qualify as personal data under the GDPR. And this because the Working Party, Data Protection Working Party, stated that hashes constitute a technique of pseudonymization and not a technique of anonymization. And so it's still possible to link the data set with the data subject. And this regarding the transactional data, always from a GDPR perspective, when we discuss public keys, the question is if they are really anonymous. So what we mean for public key, data that cannot be longer attribute to a specific data subject, a specific individual, unless it is matched with additional information such as the name or the address. When these two sets of information are combined, then the identification is possible. And that's explained why, in this case, public keys cannot qualify as anonymous data. And so they are considered personal data under the European law. And this because, yes, despite the asymmetric encryption, the identification is still possible. Public keys can be traced back to IP address, aiding identification. There are methods that exist for linking individuals to public keys by analyzing blockchain transaction and other publicly available data. And so, unfortunately, they are pseudonymous data that are cut by the European Union data protection regime. And also, unlike the transactional data that can be stored off chain, in this case, it will be not possible to move them off chain to form part of the transaction metadata required for its validation. So they're more complex case, let's say. So to recap, what is important, what is desirable is that the reversal risk, we see that there are two important risks. So the reversal risk on one side, the linkability risk should be really assessed from an early stage and on a case-by-case basis to see if there's possible to implement mitigation strategy to protect transaction and other data or introduce alternative cryptographic approaches. And so organizations should really look and consider the applicability of the GDPR, for instance, but also the California Consumer Protection Act and other privacy laws to propose blockchain use cases by carefully assessing specific blockchain implementation details, but also reviewing re-identification methods and risk, and even monitoring guidance, because I explained to you that there is a new guidance from the French Data Authority, but there could be new guidance, hopefully, on blockchain that could really guide us through the compatibility between this technology and data protection legislation. Now, okay, so data controller and data processor. We've seen already what they are and why they are important. So now the question is, in a blockchain environment, who are these key actors? Who is the data controller and the data processor? It is very complicated to identify the data controller, actually. And the first obstacle to the blockchain GDPR combination is really related to the distribution of responsibility in data control, because the GDPR is designed to apply in a highly centralized context, and so all the data protection regulation, while the decentralized essence of the blockchain seems really to have a completely different idea of control or not having at all. So the goal in a public blockchain is to allow everyone to contribute to a the updating of data on the ledger and prevent any mode of censorship. And so in this context, who is in the best position to play the role of data controller? And this is not really easy. It is the distributed peer-to-peer network means that really is often unclear which party determines the purpose and which party determines the means of processing. That is so important in order to assign the role of the data controller and data processor. Private blockchain can have a simple caser because there could be a central operator or consortium that likely could qualify as a controller or joint controller if they have control over the blockchain system, like in a traditional system architecture, and if they determine the purposes and means for any personal data processing. Also, other actors that help operate the blockchain, such as nodes or miners, can as well take the processor role. So in case of the private blockchain, it is possible to implement appropriate data processing agreement or other contract to hold this service provider accountable. But it's the very important aspect, the accountability, the responsibility, and so meet regulatory obligation. Alternative also, private blockchain, where there is a central operator performs all technical support activities, they may not have data processor or service provider by default. Instead, what happens when we do have a public blockchain, there is a lack of central operator, and this make really difficult to assign controller and processor accountability. So what we do, again, here we have the possibility to use this guidance. To use this guidance that I was discussing with you, that is the French Data Protection Authority, guidance, that will say that, for example, each public blockchain, each public blockchain node independently process the same transaction data set, at least during the block verification process. And so this can be seen as, can lead to the classification of each blockchain node as a joint controller. That's under the GDPR. Instead, if we have no entity that's clear control over the data, then a participant may try to say that there is no controller. Again, it's very complicated right now. Regulators, data protection authorities have been really slow to address blockchain technology. What I can tell you regarding the French Data Authority and this recommendation is that it's possible to distinguish between participant, accessor, and miners. And so the participant are the ones that have full writing rights to enter transaction on the blockchain, and they can send the data for validation to miners. The accessor are the ones that may retain full copy of the blockchain, but they can only read rights. And then there are the miners, that are the ones that validate the transaction and can create new blocks according to the implementation governance model. Now, for the French Data Authority, the participants are controllers regarding personal data they enter on blockchain.
You're muted, Claudia.
Oh, sorry. Okay.
One sentence.
Okay. Can you hear me now?
Yes.
Okay, perfect. So I wanted to make this distinction between participant, accessor, and miners, because the participant can be seen as controller regarding the personal data that they enter on the blockchain, because in doing so, they really determine the purposes and the means for processing. While when we talk about accessor and miners, they normally do not make these determinations, so they're not considered as controllers for the data protection French authorities. And so I just wanted to underline that, but there are even more complex questions related to the data controller and data processor, but I can see it's already 6:15, so I'm going to move to the next slide now and try to address privacy principles that are really important, especially two of them, that are the data minimization and the storage limitation, that I would like to quickly see with you. because we would like to understand if privacy compliance principle can work in a blockchain environment. We've seen in module 1 that there are many different data subject rights: integrity and confidentiality, storage limitation, purpose limitation. I underlined the data minimization in particular. So, and now that we really understand the most important issues that are related to applied data privacy rules in a blockchain world, then it is important really to see how some of the tension related to GDPR's data protection principle and the rights and obligation are can be specified deep dive into them. So first of all, data privacy do not allow to store, data privacy legislation do not allow to store personal data forever. Personal data need to be, it requires that personal data is actually deleted after it's not longer needed for a specific purpose. And it's very challenging to determine when a data is no longer needed, but anonymize the data as much as possible will really help these requirements. And this because once added to a blockchain, of course, personal data will remain part of the chain, which clearly conflict with the principle of data minimization and the storage limitation. So it is important to reconcile blockchain with the principle of lawful data handling, including the limitation principle and the data minimization principle. And in particular, in relation to the data minimization principle, the French Data Protection Authority recommends that covered entities avoid storing any personal data on blockchain. So, and where personal data is effectively stored using blockchain, then there are some additional recommendations that opt in for storing the data in one of the following formats that are the cryptographic commitment, hash copy of the data, and encrypted data. And then if not of this solution can be implemented, for example, in the case in which the data should remain public accessible, then the suggestion is to have a data protection impact assessment that will systematically be required to confirm that the residual risks are still acceptable. And now, because of the time, I will need to move to the next slide. That is the one that regards data subject rights. So can blockchain application ensure data subject rights? Again, we've seen that there are many different data subject rights that need to be taken into consideration in a data privacy environment. And so in a blockchain application, but two of them are really important and can really conflict with blockchain technology. So again, these laws recognize individuals with the right to help them to keep control over the data, allow them to choose to protect their personal data from, let's say, monetization, exploitation without their consent or justification. And so once we've established that data stored on a blockchain constitute personal data, can constitute personal data, we really need to evaluate whether data subject can invoke in a blockchain environment still their rights vis-a-vis data controllers. And so see the compatibility of the data subject rights analyzed in module 2 with blockchain. Now, I would like to focus your attention on these two, the right to amendment and the right to erasure, that is also called, is known as the right to be forgotten, that definitely present the most apparent conflict with transaction immutability of blockchain technology. In fact, many of the rights and obligations that are specified in data protection legislation seem to clash with the way blockchain store data. We already know that blockchain generally designed so the data, once written to the chain, we have seen that cannot be changed. And so immutability is a key property of the technology. But unfortunately, it is in conflict with these rules, these data privacy rules. Article 17 in particular, the right to be forgotten, say that the data subject has the right to obtain from the controller the erasure of personal data without delay. And controllers are the one obliged to delete personal data of course, subject to a number of conditions. And then we have also the right to amendment that requires that personal data needs to be accurate and up to date. Now, what can we do? Again, the suggestion is to the suggestion of the data protection authority, the French data protection authority, is to address the compatibility of blockchain technology with data subject. And what the French authority says is that while the exercise of certain rights in the context of blockchain, such as the information right, the access right, the right to portability, are not problematic, there are, of course, some rights, such as the right to be forgotten, that are problematic and almost impossible to solve. And so it recommends to the implementation of technical measure, for example, cytological solution that will make the inaccurate data inaccessible and so remove any privacy issues. And anyway, it would be important to have an evaluation. And again, the suggestion is not to register personal data in clear text on blockchain, and always favors cryptomatic solution. And so the end of this model, what we have been learned, which is the connection between data privacy and blockchain. And we have seen some of the most important issues in terms of data privacy that we really need to take into consideration while implementing a blockchain application.